I don't know. I don't know if I should thank you or just say, wow, what a tough act that was to follow, huh? I'm Andy Pease, and I'll be presenting QuickLogic. And today, what I want to talk about is how we have taken our CSSP strategy and gone from custom to catalog solutions. And that's going to be the gist of my presentation as we move forward. But first, a little bit about QuickLogic. This year is our 25th anniversary. So we are Silicon Valley based. We are a fabless semiconductor company. And what we have done is we've taken our programmable logic technology that is very unique and created a customer-specific standard product that is really geared for the mobile space. So unlike the other people that are in the FPGA business, we have taken our technology and geared it for low size, very low power, and very low cost so that we can address the needs of the mobile market. So let's see how QuickLogic fits into a system, because obviously mobile is a huge category, and where we play in mobile, we look at subsystems. So if you look at the first subsystem, this would be a memory subsystem. Here you see that QuickLogic will always be next to an application or baseband processor. So we augment the functionality that's provided by the application or baseband processor. And here you see a QuickLogic CSSP that's connected to the application processor, and in this case, it'd be memory subsystems. And in this case, it's flash memory. And the theme for all of these subsystems is we have proprietary IP that we can program inside our programmable logic circuitry. And we also have standards that are part of what we call proven system blocks. So we actually address the memory subsystem, and we also address the I/O subsystem. And something, if you'll notice here, new this year is we're actually putting motion sensors in this. So the talk by Dr. Bao was very interesting, and frankly, I'd like to talk to you after our presentation to see how QuickLogic could maybe play in that field. But here you see now a QuickLogic circuit that connects an application processor to a variety of I/O subsystems. We also have products that are geared towards the display subsystem, and here you see the application processor. We connect to that to the various displays or light engines in mobile devices. And then finally, we enable multiple radios to connect to the application or baseband processor. The thing that makes us very unique, though, from all the other programmable logic people is we not only do the programming to put these proven system blocks inside our silicon, but we also provide all the drivers that actually need to be into the application processor to make us run inside the system. And as you can see, we have all of the various operating systems that we can put inside the application processor. So what problem are we trying to solve? So we call this the OEM Dilemma. And the problem that the OEMs have in the mobile market is there are really two camps. There is the Android ARM camp that's obviously driven by Google and Qualcomm, or there's the Windows and x86 camp that's driven by Microsoft and Intel. And the way this system works is both of these camps actually provide reference designs. And they go into the various OEMs and say, here's a reference design on either a tablet or a smartphone, and we want you to use this reference design to go to market. Now, the problem with that is they take that same reference design the next day and they go across the street and give it to that person's competitor. So how do you differentiate your device from your neighbor's device when they're working off of the same base reference design model? Well, one way you can do it is you can try and do it with software and do a software overlay on the operating system. That sounds easy enough, but actually, in some cases, these guys actually close off the operating system. Certainly, Microsoft does that. But in other cases, they find out that that puts too great a load on the application processor, and it's really not a terribly viable thing to do. And what you find a lot of OEMs really want to do is they want to have a hardware differentiator inside their system. So you could actually do a customized processor, or you could do an ASIC. And while that's certainly viable in a lot of the electronics industry, in the mobile market, because the life cycle of these devices is so short, and because there's so many devices that go out to the market, this tends not to be very viable. And the cost of differentiation is too high, and also the lead time to get to market is very long, because of course to develop one of these things takes years. And that's precisely why we have taken our programmable logic and developed customer-specific standard products, which really is more than just a chip, because it really starts with the expertise that we have inside our company. So all the people inside our company are very much geared towards the mobile industry, and so we provide architectural expertise. We also provide reference design, so we go to customers and we say, what sort of value are we trying to bring? So the way we think inside of QuickLogic is we are there to try and enhance the end user experience inside the mobile space. And to do that, we need to come up with a specific solution, and then we actually have reference designs that I'll talk a little bit more about later, reference designs that give physical evidence of what we're talking about. So CSSPs then start with this architectural concept, and then we have the obviously customizable silicon. So we can take proven system blocks and customize the silicon without coming out with a new manufactured piece of die, because it is hard programmable. And then finally, we actually provide the software drivers and the firmware so that we actually offer a completed system solution, and we provide the application support. So we will always go on site with our customer to make sure that this CSSP works inside their system. Very different model from an FPGA. So that's what a CSSP is. It enables OEM hardware differentiation. It gives them very fast time to market, because actually we can do this programming depending on how many blocks we're putting in our silicon in weeks or months instead of years. And what we're always geared towards, remember I said, enhancing the end user experience. So one of the things that we're always looking at is how we can increase the battery life by having our low power circuits. Now, as we embarked on this, we've been at this now for 6 years. And what we found is that we really do need reference designs. So rather than coming to an OEM and saying, we can do anything for you, and the OEM would say, wow, that's really cool, but tell me what you mean. That's why we needed to have concepts of what we were doing. So whether it be a visual enhancement engine or extending connectivity, then we would come up with a reference design that we would go to OEMs that would basically showcase what we're talking about and give them a known good starting point to really accelerate the development. But what we also found as we developed these reference designs is, remember in that previous slide, we're always connected to an application processor. And what we found is that various application processor companies said, hey, can you help us out? And this is kind of what spurred on the idea of Catalogue CSSPs. So let's talk about what is the application processor company's dilemma. Well, the problem that they have, and by the way, if you read my bio, I spent 14 years at AMD as an executive and 3 years at Broadcom, and I basically ran worldwide sales. And I can tell you, in those companies, when they're deciding what to do with the application processor in those product planning meetings, it is a fist fight. Me as a sales guy, I want everything in it. I want every connection known to man. And meanwhile, the operations guy wants nothing in it. Obviously, I'm exaggerating, but he wants it as small and as cheap as possible. And the truth is that you're always doing some sort of compromise. So the problem is with the application processor guys is how do they address the real fillet of the market and how far down the tail they are going. And we have found this to be the case with all the application processor companies. Also, their problem is, when do you integrate a new standard? And how long does it take to integrate a new standard? And when a new standard comes out, do you want to actually integrate the standard in a chip that's in production now and respin it, which takes anywhere from 9 months to a year? Or do you want to wait till the next generation? Even a bigger problem is, how do you keep mature standards around? In other words, as all these new standards keep piling on, your silicon grows and grows, and pretty soon this is a real dilemma for the application processor companies. So that is exactly how we came up with this notion of Catalogue CSSPs. So what is a Catalogue CSSP? Well, it really started from a reference design, and now you see reference designs not only helping OEMs, but in this case it helped the application or the semiconductor partners that we deal with. And what we've done is we have really a ready-to-integrate solution, and it's architected specifically with an application processor company like a TI or like an Icera, and I'll show you specific examples of what I'm talking about. So some of you may ask, well, you know, Andy, you're kidding yourself. Really, you're just a programmable logic company, and you know, you're just like Altair and Xilinx or even Lattice. What's different about you? Well, what's different about us first is our platform diversity. And first, we have two types of silicon platforms. One is what we call PolarPro, which is 100% programmable logic. But what really makes us unique is we have a family of products we call Arctic Link products. And Arctic Link products start with that very low power, unique programmable logic architecture that we have in our PolarPro devices. And with it, we also have hardwired or full custom circuitry on the same piece of die. And we do that for two reasons. Reason number one is, as you may know, programmable logic can only do digital circuitry. And there's a lot of mixed signal and analog required in these devices. So anything that's mixed signal and analog, we need to do in a full custom proven system block. And the other reason we would do it is if we have a technology that is really pervasive across the subsystem that we're trying to penetrate, like, let's say, USB, or if you have followed us, our visual enhancement engine, that makes sense to harden that, because there obviously is a penalty for the flexibility of programmable logic, and that is larger size. So we have this hybrid of circuitry with programmable logic and hardwired logic around it to give the most cost-effective, low-power solution available in the mobile industry today. But that's only half of the story. The other half of the story that makes us very unique is our go-to-market strategy, what we call our engagement model, and that is that we deliver complete solutions, starting with reference designs, which is physical evidence or proof of concept of what we're talking about, but also including all the software drivers and firmware that would be included. And by the way, some of our Arctic Link devices actually do have a microcontroller, a 32-bit RISC CPU. So when we have that, we actually provide the firmware for our customer. Again, it's not a development system. It is a complete system solution to give our customers a unique time-to-market advantage so that they can provide something that will enhance the end user, that's everybody here in this audience, user experience. And so we have a very collaborative customer, and we probably should say not only customer, but partnership relationship. So let me give you some examples, and we picked 3 examples that really span the whole range of what we do. The first example is actually a partner that developed an application processor for a specific embedded industry, and they found out that there are many adjacent industries that they'd like to penetrate. But to penetrate those adjacent industries, they would have to have made their silicon much larger than they really wanted. So they have to develop an ecosystem or a partner that can enable the kind of connectivity they're looking for. So the first example is actually Texas Instrument. And Texas Instrument has a family of embedded processors. It's called Satara. And it turns out that in Satara line, they do not have a dedicated camera interface to enable them to hook up to cameras or optical scanners. And as they were trying to penetrate the embedded space with things like barcode readers or POS machines or remote printers, things of that nature that actually have imagery capture subsystem would need to be there, they were having to use other circuitry. So we came up with a CSSP developed specifically for TI with their general purpose mobile interface bus standard, and then we provided the camera interface that enables them to do that connection. And so when TI salespeople go out and sell the Satara for the type of customers who desire a camera, they actually have a reference design that's called a beagle bone, and there's a cape on top of it that has a QuickLogic circuit that enables them to interface with the camera. And thus, that is a camera interface, and it enabled them to go after the enterprise, retail tablets, POS terminals, scanners, home automation, and machine vision. Now, this is a great thing for us because QuickLogic is a fairly small company. We're 90 people. We have about 10 people in sales, but we leverage off of the TI sales force that when they go sell this, they actually sell the QuickLogic CSSP. But we call it a Catalogue CSSP because it's finished. Now, the interesting thing about this is, so the TI salespeople actually tell the customer about QuickLogic, and if they want the camera interface, they can do that. And if the customer is large enough, then they also say, well, you know, there is programmable logic in there, and there are other customization you could do, and they would refer them to us, and then we would do an ROI. If it's a large enough opportunity, we could really make this a CSSP for that customer, but it starts out as a Catalogue CSSP. So let me move to the next example. By the way, that first example is just gone into production in Q1, and we just got our first order a few weeks ago, I think. So the second example is actually something that's been in production, and we've shipped millions of units in this, but what the problem here was a baseband company that actually had a chipset. In this case, it was a multiple chipset radio that was trying to penetrate the USB data card market. In other words, those USB sticks that give you connectivity. And the problem is that the market had a new requirement that they didn't consider when they built the chip. And in this case, the new requirement was that the operators were requiring these data stick manufacturers to actually have the ability to add in an SD card for memory download. And they didn't have the facility to do this. In this case, we actually came up with multiple designs. Actually, over 11 months, we came up with 4 different designs that enabled them to penetrate different customers. The base of this design was always to have a QuickLogic CSSP that connected to Icera's proprietary memory bus and provided them with SDIO connectivity to connect to various flash memories. And the net story of this was this enabled Icera to go against the giant Qualcomm in this industry and capture 4 out of the top 5 guys in the marketplace with our solution in the partnership. Once again, as the Icera guys went out and sold this, they were actually selling not only their chipset, but our chip as well. Great leverage for us. The last example is actually kind of the reverse. And in this case, there are many semiconductor peripheral people, and they want to be able to connect to all different types of application or baseband processor companies. And in this case, we have companies, and we actually have 2 people, we haven't really announced who they are yet, but 2 companies that make these Wi-Fi, Bluetooth, multi-integrated modules, and they'd like to be able to integrate to any embedded or application processor. And in this case, we're developing a Catalogue CSSP, one for each one of our partners, that will enable them to have SDIO connectivity with USB connectivity into the application of baseband processor. Once again, another Catalogue CSSP. And the markets here, you can see, are enterprise retail tablet scanners. So what this enables us to do, while we have had our CSSPs have really been geared for smartphones and tablets. We know that there's a huge mobile enterprise market out there, and this Catalogue CSSP really gives us a way of partnering with companies much larger than us and being able to address a very highly fragmented market. So Catalogue CSSPs, it will really enable the end customer the ability to have expanded functionality over what the application processor natively can supply, whether it be a camera interface or it be an SDIO circuitry. The benefit to our application processor partners is it really enables them to expand their served available market without changing their silicon or without revving their silicon, and it really makes their decision much easier as to what they are going to dedicate with silicon. And I can tell you that the people that we've engaged with, we now have discussions at the CTO level so that as they are conceiving of their future family, they're deciding, okay, what am I going to dedicate to silicon, and what do I want you, QuickLogic, to be part of my ecosystem? So it's a win-win. And the benefit for QuickLogic is fairly obvious. It enables us to scale our engineering organization across multiple end markets, applications, and processors. A win-win-win. So Catalogue CSSPs. Thank you very much.
Hi. Can I understand then that the Catalogue CSSP is fixed function when it leaves the factory, or can the customer further customize that or configure that?
Very good question. Actually, a catalog, so when we send out any CSSP, we do the programming ourselves. If we have a customer that will take a Catalogue CSSP and want to add other functionality, then we will evaluate that based on a return on our investment. How large is the opportunity? How strategic is the opportunity? And we will enter into a negotiation with that specific customer and either decide to do it or not. If we decide to do it, if there's additional functionality, then we will help them put that functionality in the chip, and then we will deliver them a programmed chip. But our model does not have the customer do any programming at all. Whether it be a Catalogue CSSP or a CSSP, QuickLogic, as part of our manufacturing process, does the programming ourselves. Right. We're trying to get out, in the mobile space, by the way, we have not met a customer yet that said, gee whiz, I wish I could program it. What the mobile customers want is they want a completed solution that works in their system with the least amount of hassle.
I understand China produces 70% of the mobile phones that we use in the world today. Did you have any luck from China, any business from China, any challenges you have?
Right. So we are a publicly traded company, so I can only tell you what I've already talked about publicly, and we have already said publicly that we have a big emphasis on China. We have hired dedicated people there, not only salespeople, but architects, as well as FAEs or application engineers. So architects are more of the front-end design. FAEs are more of making sure it works. So yes, we've had very good luck in China, and China's a very important market for us.
Can you say anything about design wins and production volumes and the financials in general?
So we do this in our earnings call, and right now our earnings call for Q1 will be on May 1st. So we have talked about that we've had production wins. We had 3 production wins at the end of Q4, and on the next earnings call in May, we'll be talking about what sort of success we have had during Q1. But unfortunately, the SEC does not allow me to make those kind of revelations in forums like this.
The catalog thing you now introduce, is this a standard product, or do you have to customize each SSP for a certain customer?
So it will be how about this? It will be standard after we customize it. So what happens is that in the case of TI, so TI has this processor, Satara, and they have a reference design. So let's say they have a customer that wants to use some sort of camera interface. We will be part of that BOM, and we will actually have a part number that will look like a standard product part number. But of course, this is a piece of silicon that after it is manufactured in the fab can be programmed to look like a custom product. And by the way, that's the beauty of our programmable logic technology, is once we program our chip, it actually looks and behaves and acts like a standard product or an ASIC. Very low power, especially in the static mode.
And in most cases, you program your chips, or the customer buys your technology to make its own programming?
Yeah, so in all cases, the customer will buy a completed solution. So, as a matter of fact, even though we have distributors, if you think of the FPGA model that many of our competitors use, they will actually have their unprogrammed chips at a distributor. We don't do that. We actually have finished either CSSPs or Catalogue CSSPs at our distributors, or we ship them directly to our customers. And by the way, one other interesting point about this is when we got into this business, obviously we have our own programming tool like any FPGA company has. But as we embarked on this, what we realized is when you have your own programming tools, how you program the programmable logic, we have optimized this for the mobile space. Because if you think of what the programming tools that are available from the competitors, it's all about ease of use and the GUI interface and so on and so forth. We don't care about that. What we're really caring about is optimized performance, especially power, and the ability to put as much logic in our programmable logic as possible. Yes, sir.
You talked about a relationship with TI. And you stressed your importance in the mobile space, but my impression is TI has stepped back from the mobile space. Can you talk a little bit about the relationship?
Sure. I'd be happy to. Actually, TI has stepped away from the consumer mobile space. In other words, their consumer application processor was known as OMAP, and they've already notified people that they're getting out of that business. But make no mistake, TI is full bore bent on capturing the embedded market. And by the way, the embedded market is every bit as large as the consumer market. It is just more fragmented. So you have to have a much different go-to-market strategy in order to serve all of these fragmented markets. And frankly, for QuickLogic, the embedded or mobile enterprise market is an ideal market for us where customization is critical and imperative. And by the way, if you listen to my last earnings call, I made it a point of calling TI a partner, and I don't use those terms very loosely. As a matter of fact, before I made that comment, I actually called my general manager contact and said, is it okay if I call you a partner? And he said, absolutely. You're a very important part of our ecosystem. So I think that's a very good sign for us.